So this video will go over section 6.6 on Le Chatelier's principle. So Le Chatelier's principle states that when a stress is placed on a reaction at equilibrium, the system responds by changing the rate of the forward or reverse reaction in the direction that relieves that stress. So there are different possible disturbances that can be looked at. First, the concentration changes, temperature changes, and pressure changes. We'll go over concentration and temperature changes. So let's look at what this Le Chatelier principle means in practice. And let's start with concentration changes. So we have this reaction of two carbon monoxide molecules reacting with one molecule of oxygen in equilibrium with two molecules of CO2, all in their gas phase. So what happens if the concentration of carbon monoxide is increased? Remember how the brackets around the formula means concentration in molarity. So if we are increasing the concentration of one of the reactant here, so Le Chatelier principle says that it will want to counteract the change and do the reverse of what the change is doing. So here, if it increases the concentration of the reactant, then the equilibrium will try to consume that reactant to counteract the increase in concentration. So to consume the CO here, we will have to have the forward reaction go more than the reverse reaction. So this will drive the reaction to the right. And so the equilibrium will shift to the right and consume the CO with oxygen to form more CO2. So the rate of the forward reaction is increased to form more product until the system is again at equilibrium. And we say that the equilibrium shifts toward the product or to the right. Let's look at another concentration change. Still with the same chemical equation. What happens if the concentration of CO2 is increased? So this time we are increasing the concentration of a product, the only product here. Adding more product, what does it do? Le Chatelier's principle says that the equilibrium will try to counteract the increase of product by consuming product. So to consume more product, then the equilibrium has to be shifting to the left, and then from the product to go back to reactant. So the rate of the reverse reaction will increase to form more CO and O2 reactant. And the equilibrium will shift towards the reactant. So we say that the equilibrium is driven to the left. Let's look at another example of a concentration change. What happens if a product is removed? So here we have another chemical equation that has ethanol on the reactant side in equilibrium with ethylene and water. Ethylene and water are the product. And let's say we are removing water, one of the product. If you are removing water, then Le Chatelier principle says that the equilibrium will try to replenish the water. And for this, it will have to drive the reaction to the right and produce more water and ethylene. So the rate of the forward reaction will increase and form more product. Let's look at some temperature changes now. So we have a new chemical equation here with N2 plus O2 in equilibrium with 2 NO. So this is an example of endothermic reaction because the heat of reaction, the delta H here, is a positive 43 kilocalories per mole. It's endothermic, which means it's a reaction that needs energy, needs heat to occur. So let's say now the temperature change is an increase in temperature. So when the temperature is increased, the reaction that absorbs heat will be favored. So here, if we are increasing the temperature of the reaction vessel, given that's an endothermic reaction, this will favor the endothermic reaction because we give the heat that is necessary for the reaction to occur. So this will drive the reaction to the right. So an endothermic reaction absorbs heat, and so increasing the temperature favors the forward reaction. Let's look at a different chemical equation and a different temperature change. So here, nitrogen is added to hydrogen to make ammonia. So N2 plus 3H2 are in equilibrium with 2 NOH3. And the heat of reaction, the delta H for this reaction, is negative 22 kilocalories per mole. A negative heat of reaction means it's exothermic. It's an exothermic reaction going forward. So if we are increasing the temperature, um, it's not going to favor the exothermic reaction because this would produce even more heat. So when you increase the temperature, you will favor the endothermic reaction, and the endothermic reaction is the opposite of the exothermic one, which means it's the reverse reaction. So increasing temperature will favor the reaction that absorbs heat, and this will drive the reaction to the left. An exothermic reaction releases heat, so increasing temperature favors the reverse reaction. And conversely, when the temperature is decreased, so think about what it means to decrease the temperature. If you decrease the temperature, you're removing heat, and so the reaction that had heat will be favored, because if you're removing heat when you decrease the temperature, Le Chatelier principle says you will want to, the equilibrium will want to add heat, to counteract the change. So then the reaction that adds heat will be favored. So this is a summary of the effects of changes in conditions on the equilibrium. And so we have looked at changes of concentration and changes of temperature and the effect on the equilibrium. So you can look at this as you need help when you are doing exercises on Le Chatelier's principle. So let's do some learning check here to test that knowledge. So indicate if each change on a reaction at equilibrium shifts towards the product or the reactant, or does not change the equilibrium. So we have this reaction where 2 NO2 gas, and you need heat. So that means it's an endothermic reaction. You need heat to go forward and make 2 NO and plus oxygen, all in their gas phase. So we have this equilibrium, and it's an endothermic reaction that requires to absorb heat to go forward. So what will adding some NO do to the equilibrium? So NO is one of the product. So that means you're adding a product. If you're adding a product, the Le Chatelier's principle says that the equilibrium will try to consume that product. And to consume the product, then it favors the reverse reaction, and it goes from right to left. So it will favor the reactant. So the equilibrium will shift towards the reactants. What happens if you are raising the temperature? So you're raising the temperature, which means you're bringing energy, you're providing heat. And here we have an endothermic reaction that needs heat to go forward. So this will favor the forward reaction, because you provide the heat that is needed for the reactant to react and become the product. So the equilibrium will shift towards the products. And the third case, what would happen when you are removing some NO? Removing NO is like removing a product because NO is a product. So if you're removing a product, Le Chatelier's principle says that the equilibrium will try to replenish the product. And so to replenish NO here, you will need to have the forward reaction go on. And so this will favor the equilibrium to go towards the product and towards the right.